Hello students, welcome. Myself Princy Evangeline, handling physics for grade 12 at Vailankanni Senior Secondary School. We are going to see experiment number 3, which is law of combination series. This is same as the experiment number 2, which is the resistivity of wire using meter bridge. But there is one small change, which we are going to have two unknown resistance, and finally we are going to connect those two unknown resistance in a series connection, and we are going to get 3 calculations. So that is this difference between experiment number 2 and experiment number 3. Now let us see the aim for this experiment. We have to find the determination of resistivity of a wire using meter bridge and to verify it with the law of combination series. Now let us see the apparatus required for this experiment. First we have to need a meter bridge. So this is a meter bridge. And then we need a battery eliminator, which is the source of electricity. And then we are having a known resistance box. Then we are having unknown resistance 1, unknown resistance 2. And then we are having a one-way key, a jockey to connect it with the meter bridge, and we are having a galvanometer. So these are the apparatus required for our experiment. Now let's see the circuit diagram and we can see the connection for the circuit. So here we are having the circuit diagram for meter bridge. In the meter bridge we are having 2 points A and C. In the middle we are having another 1 point. Here we are connecting the batteries positive to the meter bridge A and the negative is connected to the key, and the other side of the key is connected to the C of the meter bridge. In the middle we are connecting the galvanometer to the resistance box. In the upper side of the meter bridge we are having 2 gaps. In the left hand gap we are adding resistance box, and in the right hand gap we are having unknown resistance. Here we are having the battery eliminator. This battery eliminator is connected to the A side of the meter bridge, and the another side is connected to the key. And this key is connected to the C side of the meter bridge. We are having 2 gaps. In one gap we are adding the unknown resistance, and in the another gap we are connected the known resistance. And we are again connected the galvanometer in the middle, and the other negative of the galvanometer is connected to the jockey. So in this circuit we are going to change this unknown resistance for the next calculation, and finally we are going to add this unknown resistance and another unknown resistance, and we are going to connect it series in a connection, and we are going to find the calculation. First we are going to take the reading with this unknown resistance, and for this unknown resistance we have to change 3 ohms and take 3 readings, and next we are going to change another unknown resistance, and for that also we are going to change 3 ohms and take 3 readings. Finally we are going to combine this unknown resistance and the second unknown resistance in a series connection, and then we are going to take the reading for 3 ohms. Finally we have to find the mean value for all the readings. First, for the first unknown resistance we can take the value for ohm 1. The deflection is showing fully. We have to move it gradually until it shows null deflection. So at 35 we are having null deflection. So we can take the L as 35. Next we have to change the ohm to 2, and we have to do the same process. We have to move it gradually until it shows null deflection. So at 37 we are having null deflection for 2 ohms, and for finally 3 ohms we have to take the jockey and move it gradually from one direction to another direction. The deflection is showing fully. We have to move it slowly until it shows 0. So at 50 we are having null deflection. So in the next we are going to change the unknown resistance, and we are doing the same thing with the different unknown resistance. Now we have changed the unknown resistance to. So for the same thing we have to repeat the same process from ohm 1, ohm 2, ohm 3. So we are going to do the same thing, moving it from the edge to the null deflection. Here it is 68. So likewise we have to take 3 readings for 3 different ohms in the unknown resistance 2. Finally we are going to combine unknown resistance 1 and unknown resistance 2 in a series connection, and we have to do the same process with 3 ohm values. Now finally we are connected to unknown resistance. We are going to take the deflection, null deflection for this for 3 ohms and take the values. First we can move from here. So at 62 we are having the null deflection, and likewise we have to change ohm 2 and do the same thing. So at 71 we are having the null deflection. For ohm 3 we have to take the last reading. So at 74 we are having the null deflection. So finally we have to take the mean average for unknown resistance 1, unknown resistance 2 and finally connecting them in a series and taking the final x1, x2 value all together. So this is the tabulation for this experiment. We have to take 3 readings for each unknown resistance. First 3 readings for 3 different ohms for the same unknown resistance. First value we got 61 as L centimeter, then we have to minus it with 100, then the value is 39. Finally we are getting the resistance by applying in the formula 100 minus L divided by L into R. R is the resistance ohm. So this is 1.9. Likewise we are having 3 values for a single unknown resistance and then the mean value for those is 1.8. Likewise, for the another unknown resistance R2, we are taking the same 3 different values for 3 different ohms and we are getting a mean value. Finally, we are connecting unknown resistance R1 and unknown resistance R2 in a series connection and then we are getting the mean value as 3.2. So, we are having 3 different mean values. So, the result for this experiment is that with using the meter bridge, we have find the determination of the resistivity of the wire with using the law of combination series. So the things that you have to keep in mind while doing this experiment is that the copper wire should be very thick and the galvanometer should be of appropriate range. So that is for this today's video. We can see the next experiment in next video.